Alright, good morning. Alright, so anybody that didn't see our last stream, last week we worked on decoding a SteelSeries controller for use with InputMapper 2.0's upcoming firmware. This time we have a Ouya controller, and for those of you not familiar with it, it's a controller that comes with the little Ouya Android set-top TV box. This controller kind of flew under the radar for me. I wasn't really even aware of it, despite it having some interesting features such as a trackpad, just like the DualShock 4. I really didn't know about it, and once I got it, I know why I didn't hear anything about it. It's not an entirely impressive controller, despite having an innovative feature such as the trackpad. I'm not going to go into a review of the device or anything, but let's just suffice to say it's not going to be replacing my DualShock 4 for any gaming. But nonetheless, some people have the controller, so we are going to decode it to work with InputMapper here. Alright, so first off, there has been some work done on the framework. Anybody that saw the video last week saw that there were some bugs. It kind of fought back with us, but we did change a lot of stuff, and we'll get into that once we launch up the actual template and the framework. For now, we're going to go ahead and just connect the device and start working on decoding the data contained within it. And I already have it paired up. I'm using Bluetooth. Actually, I have to use Bluetooth. The Ouya controller, that's the only option you have. There is no USB. It's Bluetooth or nothing. So, I have it paired up, and I'm going to go ahead and launch my HID packet decoder. And I'm also going to have to go into my devices and printers and find out what this product's product ID and vendor ID is. So, coming in here, Ouya game controller. It looks like a mouse and keyboard icon, but that's the actual game controller. So we're going to go into the properties there. Take a look at the hardware. There's the Bluetooth HID device. You can open that up. Details. And hardware IDs. And here's our big long connection string, which has our vendor ID and product IDs that we need in order to connect to the device. So it looks like the last four digits here are going to be 2836 with a product ID of 1. Alright. So we go into the device listener here. This can be downloaded from our InputMapper website if you have a developer account. If you don't have one, just contact me by email or through the website forums. The link will be posted into the video at the bottom. Alright, so vendor 2836, product ID 1. There's two instances of the controller. I'm not sure why that is. One of them doesn't seem to do anything. I've tried this out before. The only difference here is there's a COL01 and a COL02. We're going to go into the first one and launch our listener. Alright. So, here is our packet layout. It's a 12 byte array. Alright, starting off here, 1 through 4 are our sticks. 1 is left stick x-axis. The ports 0 always seems to show a 7, even when I was testing it out before. I'm not really sure what the purpose of that is. It's probably just a state indicator. It might also have controller ID or player number mixed in with it for when it's paired to an Ouya. Because when the controller is connected to the computer, it actually shows like a player 1 icon. There's one LED lighting up when there's spots for 4. So we're not going to worry about that. We're going to skip right to channel 1 here, which is going to be our left stick x-axis. And contrary to what we had to deal with the Steel series. This is more traditional. It's left throw is at 0, full right throw is at 255 with 128. Excuse me, 128 being our middle value. So I mean that's linear. So we don't have to do anything crazy like we had to do with the Steel series. All right, so moving on. Position 2 is going to be our y-axis with 0 at the top, 255 at the bottom. Position 3 is going to be our right stick x-axis, 0 left, 255, and continuing on 4 is going to be our y. So go ahead and fill that in, nothing special there. Anybody that's watching this live, I'm not in the chat. I got too many windows open as it is, so I don't have that up on the screen. Alright, so moving on. There's looks like 5 is going to be our left trigger, and that's also just a linear proportionate value there from 0 to 255 for fully pressed, 0 for released, so that's easy enough. Six is the same for our right trigger. Seven's going to be all of our buttons. Shoulder and face buttons. Alright, so we got to write down what all of the values are for those buttons. Alright, just start with the lowest value one, which is going to be the O. And the Ouya controllers have the face buttons instead of like A, B, X, Y. It's O, A, U, Y. So it's a weird controller. Alright, so the O is going to be a 1. Let's see. The U is going to be our 2. The Y is 4. And the A is 8. And then we have our shoulders. Left shoulder is going to be 16. Right shoulder is 32. Alright, now we got our D-pad. Unlike traditional D-pads, which use a clockwise, just a linear numbering, this one actually looks like it uses some sort of byte shifting. Yeah, okay, so we got 1, 2, 4, and 8. Alright, so that's easy enough too. And that was on position 8, okay. So 1 is going to be our up. Down is 2. Left is 4. Right is 8. Okay, that has all of our standard controls there. Yeah, okay, it doesn't look like, I can't, at least not that I'm noticing, it doesn't look like the actual power button registers anything. So we'll skip to the trackpad. Unfortunately, I like the DualShock 4, which also has which sends the trackpad information as an XY coordinate system. This is using Delta, which limits it, where you're not going to be able to use it for too many macros other than like swiping and stuff like that. You can't do a positional like tap left, tap right kind of deal because it doesn't send the coordinates. But it can be used for mouse control since it has Delta. So position 9 is our tap indicator. It's just a 0, 1. Uh, 10 is our delta X. And that uses the left is a split byte, so it's split right in half, so 0 is at the center. So let's see. Actually, 128 to 255 is our left value, with 255 being the small. And then 0 to 127 is going to be our right, with 0 being the small. So it's kind of like the Steel Series controller where they split the byte and then reversed one side of it. I'm not sure why they do that, but whatever, it works. We can figure it out. Channel 11 is going to be our Y, our delta Y. And it's going to have the same issues as the X. Okay, so that's the report structure for the Ouya controller. So now we just jump right into coding here. Alright, we're going to start a new project here. And we're going to ODIF input device. Call it Ouya controller. And open up our device.cs. Alright, now, so those of you that saw the last stream that we did, you'll remember that we had to rename all kinds of stuff, and because the template didn't really create the device properly. That's all been fixed. The new SDK template creates the device. It's pretty much buildable, ready to go right from the get-go here. So all we have to do is start adding R. We're going to reference the HID library here since this is a HID device. So that's where we'll start. HID device. All right. I'm going to open up a different controller here in a different window so I can kind of cheat off of it as we go along here. I've done this enough time, you think I'd memorize all this stuff by now, but I don't. Alright, Starting with the constructor here, we're going to go ahead and create a new instance of the HID device enumeration class. We're just going to create a list of devices that we find that match the hardware ID and the product ID that we're using for this controller. And the library that we referenced as a function that allow us to search the computer by hardware ID and product ID to find such devices and then create instances of it. So I've already forgotten what the hardware ID and product ID was. I have to open up my device manager again. Better yet, I'll just open up the packet. 2836 and 001. Okay. Alright, so that'll create an instance for each device it finds that matches that. Now we have to iterate through this since we get 2 instances of each device. We have to iterate through that and differentiate the two and make sure that we create our actual device list using only the ones that we know that are returning proper packets. And I'm going to do that by using the packet length. Even though I know there is a differentiation between the connection string here, I'm not sure if that's going to always hold true because I only have one controller, so I'm just going to go by packet length. This one I know has 11. This one returns 7, and I still don't know what this is even for, so we're gonna use some link and just strip out the ones that don't have a report length of 11. So I think a for each is probably the best way to go about this. Let's see, somewhere in here there's a way to figure out the report length. Not attributes. Capabilities. Feature report, input report byte length. There we go. And we're only going to grab the ones that have a length of 11. Okay, so that should filter out the devices that we need. All right, now we're going to jump down here real quick. And since now this is where we're going to actually be creating an instance of the actual input device, the Ouya controller device for the plugin, and storing it into the list of devices for the actual plugin, I'm going to go ahead and come down here and create the constructor. And as we learned on our last video, passing the HID device instance through constructor is the easiest way to do this. So we're going to go ahead and do that. Create a local property that has that. That can be private. As easy as that is, I hope. Alright, so now we can come back here. Now that we have that constructor in place, we can say our devices collection here. Go ahead and add. And this. Okay, so there we go. That's creating our new instance of the actual Ouya controller device class here and passing the HID device handler as a reference into the constructor here. Alright, so now that's pretty much all built. There's a bunch of other stuff that we could add into here, such as we might need to expand dispose to actually close the connections on each device before removing them. But that's more advanced stuff. We won't worry about that for now. We'll just get the basics out of the way for now. So we're just going to come down here to our actual device instance here, and we're going to build our listener. Alright. Well, actually, first we're going to build the channels. Those of you that saw the older version of this, you'll remember that I had the field was actually getting the channels from an inline defined property. I've decided to move all that stuff into the constructor as well. So we'll define our channels from within the constructor here. It'll look a little cleaner and be easier to debug if we ever need to. Alright. So we're going to start adding all of our controls. We'll start with the sticks. And let's see. And we're going to also define our minimum and maximum values for the channel while we're here. This is a linear stick, so there's really nothing to it here. Minimum 0, high of 255. But actually, I like to split it. I like to put 0 right in the center. So we're gonna change this a little bit. Make the minimum negative 127 and the high 127. We'll have to change some stuff in the actual listener to make it meet that standard. But it's easier to read code-wise if 0 is in the center and then we have negative for left throw, positive for right throw. So that's what I'm going to do with all the axes here. Okay, now we're going to add our buttons. Oh, I should change the name here as well. Did not mean to do that. But, all right. Okay, so we got the O, U, Y, A. We also have two triggers I forgot about. I'm going to put them up here with the axes. And the triggers are going to be 0 to 255. We got two shoulder buttons. And then we have our different D-pad directions. Alright, then we have the trackpad, which is, again, two axes and a button. Call this trackpad delta X, trackpad delta Y, and then trackpad button. And I'm going to go back to the 0 in the center standard for this. Alright, don't think I missed anything. Oh, actually I did completely miss something. There are clicky sticks for the left and right stick. You can click in on them. I didn't even grab that when we were debugging the device, so I'm going to jump back and do that real quick here. Alright. Oh, the device went to sleep here. Alright. That's on 7? Okay. That's left shoulder, right shoulder. Let's rename them to left bumper, right bumper, because I want LS to be left stick, right stick. Alright, so our left is going to be 64. Should be 128. Yep, 128. Okay, now that we got that squared away, I'm going to rename them here as well. So these are, instead of shoulder, we're calling them bumpers. Just so our naming standard doesn't get confusing there. And then we have our two sticks. Okay, that's all figured out now. Okay, so time to create the actual thread that's going to be housing our listener. We'll keep this private as well, no reason to make that seen by anything. We're going to have to add a reference to system Windows threading. Alright. So inside of our constructor, we're going to create that thread and go ahead and start it. Alright. I'm wondering if I should pass an instance. No, because I think that... I think that runs on the same thread as the actual class here. So I don't think I need to pass any references. We'll give it a shot, see what happens. Okay. Before I get too far here, let's go ahead and add some resources here. And these are just a couple of icons I have here for the device that we'll use in a couple places. We got the company logo and the actual controller logo in there. Alright, so jump back here into the device. I'm going to add that to the constructor as well. Okay, back to the good stuff. Alright, now we're going to create a empty byte array. Which is going to house our input report that we get from the HID device. Let's see. length is 12. There we go. Alright, so now we need to create a while loop. This is kind of taboo to do a while true because there's no clean way to get out of that. But if, when you're doing your device, it's a good idea to have an actual Boolean stored somewhere publicly accessible that you can switch to allow it to cleanly exit this loop if you so desire. For testing purposes, though, when I want to stop it, I'm just gonna kill the thread. It's not clean and it's not the right way to do it, but it'll work for us for now. Alright, so now we need to connect to that device and store that input in it. But first, speaking of connecting to the device, we actually need to open the connection. So what we'll do here is we'll do that towards the end of our constructor here. But before the thread. And all we got to do here is I'll do an is already open check just in case something else is using it. Alright, this is going to give us the option for a Boolean here, which is whether or not we're connecting exclusively or not. This will be handled at application level through a variable that's passed to it, but for now, since the InputMapper application isn't fully developed, I'm just going to go ahead and say false. I'm going to let it remain a public device so I can diagnose it with multiple applications at the same time if I need to. Alright, so that should actually open the connection there. So now that that's open, we can actually get our input report, which is going to be done through read file. And then we're going to store it into our input report byte array. It's as simple as that. And then since we're in a loop here, I'm going to go ahead and add a check to make sure it's properly connecting or getting proper packet data and everything. So we're going to say actually, that's a return the read status. This will return a bool. So we'll put that right into our check here and make sure it's a success. Okay, there we go. That way, we're only going through this loop and doing anything if it actually reads a successful file from the device. We don't want it to hang if it's having problems communicating with the device. Okay, now that we have all that, we can start using some bit operations and storing the data that we're getting from the controller into the channel information here. So Let's start with our axes. Alright, and our LX is on the channel 1. And since I shifted it, usually it's a 0 to 255, but I've shifted it to put 0 in the center, so we are going to have to do some quick math here. We subtract 127 from that byte, and that should move the 0 value back towards the center. And this is pretty much going to be the same across the board for all the axes of both sticks. The only thing we got to change here is the actual report channel that they're coming in on. Alright, let's do our triggers while we're here. I'm not going to be shifting that. I'm going to let that stay the way they are. And our triggers come in at 5 and 6. Alright, so I'm going to go ahead and build this real quick. Test it. Make sure that we're not completely way off course here. Alright. The device disconnected again. Try that one more time. Well, for whatever reason, the device is not connecting. It might have something to do with my link expressions when I was filtering through devices here. So let's see what we got. Create a breakpoint here and make sure I'm actually getting devices. Or maybe it has something to do with this being open. Maybe, oh. Maybe that's stealing the connection. Nope. have to dump this and figure out why it's not working. Okay, according to the console window here, found 2. So it must have something to do with the link filter that I'm using, as I suspected here. You know what I think it might be? I think this is a base 1 count, and the number that I'm getting from my packet listener is a base 0. So let's go ahead and try shifting that. See? Let's see if that's our issue. Oh, okay, I'm getting a null reference on the input channel array in the plugin here. And that is because I did not initialize the actual list before I started adding stuff to it. That is my fault. This is going wonderful. Almost as great as the last stream. Let's give this another shot here. There we go. Everything works. It's awesome. Okay. The controller doesn't have a name, so nothing is showing up next to it. Let's go to the import monitor and see if we're picking up anything from it. Yeah, okay, good. Alright, so everything that we've gone through so far looks like it's working. I want to flip these axes here just to make a little more sense here. Let me turn on the camera here so you guys can see. If you look at the LX value, I would like my left to be the low value in my... Yeah, that's reversed, I think. Maybe not. No, maybe that's correct. Okay, yeah, that's the low value, high value. Okay, yeah, so everything's perfect. Yep. Cool. So now on to buttons. Alright. And we're just going to start with the face buttons here. And to do that, we're going to have to do some bitwise operations. And this can get a little tricky, but there is an clicking all kinds of stuff now. There is an easy way to do this. Alright, so if you remember in my last video, a certain channel that stores button information. One channel contains information for a bunch of different buttons. In this case, it's all of the buttons except for the D-pad. And the way they do that is by using doubling values here, 1, 2, 4, 8, 16, 32, so on and so forth. And the reason they use doubling values is if you combine any number of these values here, it's never going to equal any other combination. So using that, you can store, multiple buttons into one channel instead of, expanding your report to be more channels and thus using more bandwidth. So, going by that standard, we're going to go ahead and write out our doubling values here. And 128 is as high as this goes. Alright, and then what we're going to do is we're going to do a base 0 count of how deep in each of these values are. So that's 0 in, that's 1, 2, 3, 4, 5, 6, 7. Alright, so now that we have that, when we come over here, we're going to start with the channels. And we're going to start with our O, which is going to be 1. And to catch that, I'm going to go ahead and grab some code from a different window since I already have it typed out. Oh, input report. That's my bad. Alright, so this is the only thing you really need to worry about here. And that's telling it that, that's the actual shift amount, or the numeric value of how deep in the value is that we're looking for. So O at a value of 1 when pressed, and 1 is 0 deep. So if this equals true, it'll say that button's pushed. And we're going to go ahead and we're going to do the same for all of our other face buttons here. Alright, so our U is at the value of 2, which needs to be shifted once. Y is a value of 4, which needs to be shifted twice. A, value of 8, needs to be shifted 3 times. So those are all in order. Nice and easy. We'll go ahead and build that, pop it in, make sure that works. Alright, go to our input monitor here for the Ouya controller. And there we go. O-A-U-Y. And there you go. You can see that holding multiple ones down at the same time, even though they're all contained in the same channel in the byte report, we're able to get data for all of them. Alright, so that's how that works. We got all that. Our axes are good. The D-pad is also using, unlike the D-pad on other controllers where, like I said, it's a clockwise representation of 1, 2, 3, 4, just numerical order. This is actually also using like bitwise shift operators, so you're going to treat this the same as you do the buttons, so we won't get into that. Instead, next, we'll do a little work with the trackpad here. Alright. So that all works. We'll just worry about catching the delta values on the trackpad. we're going to do is this value is flipped around. The left being 128 to 255, with 255 towards the center, and the right being 0 to 127, with 0 being towards the center, which isn't in order if you're thinking about it from just left to right going across the trackpad. It's not in order at all, so we got to do a conditional statement here to determine whether or not we're swiping left or right, and adjust our interpreted delta value to reflect that. And those of you that saw the Steel Series debugging video, you might pick up on that as being the same exact thing that the Steel Series used for their stick axes. So luckily we have that statement pre-written. I'm just going to go ahead and bring it in. Change a couple variables to reflect. And then of course we got to change our channel values. Delta X is on 10. So I think this should work right out of the box. It doesn't hurt to give it a shot. Let's go ahead and build it and see what happens. And what I should do is, thinking out loud, some of these common like byte operations and stuff like that, I should come up with like some sort of an extension library to do this stuff for you guys, so you don't have to worry about futzing with all this minute details and code and all that. So I'll do that at some point, so you guys don't have to even worry about this stuff. I'm getting a key not found exception on that. Oh. It is case sensitive, and I had a lowercase x in there. That's a silly mistake. There we go. Alright, yep. Okay, so I'll switch on the camera here again so you guys can follow along. My left swipe is dragging that delta value down. My right swipe is bringing it up. So using that, like I said, it's not positional data like X and Y coordinates like the touchpad on the DualShock has. But using delta, we can interpret that stuff into mouse movements. So at least we can move the mouse around with that. We just won't be able to detect. You see, it does nothing if I'm just clicking on the left side, right side, top, bottom, nothing like that. So we won't be able to interpret, stuff like, left click for back, right click for start, like some people like to do with the DualShock. So that's unfortunate. That's in the controller design. There's nothing we can do about that. But I think that'll do it for this stream. I think we certainly a lot smoother than last time. We kept it under an hour here, it looks like. And we got the major components of the controller to be recognized and decoded. So, that said, you can expect the Ouya controller to be part of InputMapper 2.0's compatibility on its initial rollout, including touchpad support. Alright guys, thanks for watching.